Hello, everybody. My name is Daniel Moreira, and I'm here today to talk about our work entitled Performance of Humans in Iris Recognition, where we evaluate the impact of iris condition and annotation-driven verification. This work was developed in the University of Notre Dame in collaboration with the Warsaw University of Technology. So, as the title suggests, we are dealing with iris recognition, which is essentially the task of giving the pictures of two irises and telling if they depict the same eye or not. So, if you go to the literature and take, for example, the work of John Dogman from 2006, you will see that the solution is pretty good. He is able to process 200 billion comparisons, and his solution delivers nearly perfect match rates. If you take a look at the solution, you will see that usually what they do, they strip the irises, then they apply some filters like Gabor filters or Bessy filters, and then you have the outputs where you use a threshold to have binary code, which you compare with Hamming distance, and in the end you have a number. And based on previous observations, you know that if that distance is below a threshold of 0.32, for example, you have the same eyes. Easy, right? Yeah, maybe not so easy for the everyman. So this is the motivation here in this work. How do we make iris recognition a more human intelligible process? It would be useful, for example, in a court of law where you are trying to convince a jury when you're presenting iris recognition results. So to do that, we decided to start by observing humans and answering the following question: how do people perform iris recognition? To do that, we conduct experiments with people, showing them pairs of irises. And we tried different iris conditions. One of them was healthy eyes that were easy and hard for computers, disease-affected eyes. We had irises from twins, which interestingly, they are not hard for computers, but for people they are highly confusing. We had also irises with difference in pupil dilation and also irises of deceased people, which, contrary to the common sense, are still useful for iris recognition. And when we conducted experiments, we had two sessions. In the first session, we were simply asking people to select an answer. So we had five options. The first two were for the same person, being certain or likely, or different people, certain or likely, or uncertain. And then the person should select one of those. The second session, we had an annotation-driven session where people annotated matching and non-matching features. So they used green for regions that are the same and red for regions that were missing. Here you see an example of the annotation tool that we have used in the experiments. And by doing this, we had some nice findings. For example, people performed better when they annotated their irises. Also, the most challenging cases to people were pupil dilated and twins. And people were better than computers in diseased and disease-affected samples. So if you have questions on how did we select hard samples for computers, or what software did we use, or how did we collect irises, and how many people did we have, please pay us a visit.